Okay, first of all, the original energy bar graph there makes sense to me. The block is held at rest, so that's why we have 0 joules of kinetic energy. And the spring is just kind of sitting there. It's not been squished yet, so it also has 0 joules of potential energy there. So the block is raised at a certain elevation. The reference height is labeled right in the diagram. Okay, so there is going to be some positive amount of gravitational potential energy, and the graph says it's 100 joules. So add those three numbers together, the total is also 100. Now for part A, we're going to have the block just touches the top of the spring. Okay, so that's part A. So at that point, let's see if we can figure out the energy bar graph here. I'll start with the gravitational potential energy. So now the block has basically reached the reference level. Okay, it's basically reached the reference level. So I'm going to say it's got 0 joules of gravitational potential energy. Kinetic, I'm going to skip that for now. I'm going to head to the elastic potential energy due to the spring. So at part A, the spring has still not been squished yet. Yeah, the block just got there. It has not squished the spring yet. Compressed is probably the better word. So it still has 0 joules of the spring potential energy. The total needs to stay the same, the law of conservation of energy. The total still needs to be 100. So all of that 100 joules is kinetic energy. So basically what happened was direct transformation of energy from gravitational potential energy into kinetic energy, all of it, all 100 joules of it. We are ignoring air resistance. We're going to ignore thermal energy in this question. Part B, in part B, the spring is going to get squished. So here's my new diagram. The block, let's change colors to make it a bit more clear. The block has now squished the spring a bit. I extend the reference level. The block is now a little bit below the reference level. Not by much, but a little bit below the reference level, and the spring has been squished a little bit. Further, they say it has been squished to maximum compression. Maximum compression. That means that's squished it as much as it's going to squish. It's not going to go any lower than that. At that specific point, one thing to understand is that the block comes to a rest at that exact point. It's just for an instant because the spring's going to push it back up very shortly after. So this is just for an instant. But this is the instant we are drawing our bar graph for. Okay, so I'll start with, well, I'll label the axis first. So I'll start with what I know. I know the total is going to be at that 100 joules, law of conservation of energy. Now, based on what I wrote, the block actually comes to a stop at that moment, makes the kinetic energy here 0 joules. Okay, so now the other two bars, the two potential energies, have to add up to 100. It doesn't really say much about the mass or the spring constant or anything like that, so I can kind of make up two numbers that add up to 100 joules. However, one of them has to be negative. the gravitational potential energy is actually going to be negative because of where the reference level was set. Okay, the reference level was set at the top of the spring when the spring was not squished at all. Well, now the block is below it, so it's going to have to be a negative something. I'll say negative 20, just make up a number there. So that's the gravitational potential energy. So if it's negative 20, then what does that mean about my elastic potential energy? Well, it's got to be positive 120 so that everything adds up to the total of 100 joules.